Hello, hello, hello. I'm coming your way once again with another interesting series. This is the academia series. We have completed our series or presentation under the topic light energy, and we are starting a new one on elements, compound, and mixtures. Please let's get interactive by contacting me through the email displayed on your screen. You can also use the comment section under my channel also to pose your concerns. Today, at the end of the lesson, these are the learning objectives that we should expect. And I believe learners will be able to explain the terms element, compound, and mixtures. They should be able also to classify materials as elements, compound, and mixtures. And then lastly, I expect them to write out chemical symbol for the first 20 elements and more. Now let's start today by revising on the 3 building blocks or unit of matter. Every matter you see around or feel around is made up of 3 basic units. It can either be atoms, molecules, or ions. Let me repeat that once again. Everything you see around, the smallest unit which were put together to form that object or that kind of matter, we have 3. It is either made, that unit can be atom, molecules, or ions. Let's take a look at an atom. What is an atom? It is the smallest particle of matter that cannot be broken down by any chemical means. Let me explain this statement carefully. Let's say I have a piece of wood and I realize that piece of wood, its smallest unit is atoms, meaning a lot of atoms has been put together to form that piece of wood. If I use any means to break down that atom of the wood into something simpler or something smaller than the atoms of the wood, it means I may have formed another form of matter. I can't say what I have formed is still the wood, no, because I have destroyed that atoms of the wood. Maybe by so doing, I have formed an atom of, let's say, another metal. So what I'm trying to say here is that with respect to matter, whatever atom that combines to form that matter, you can't break it down any further. If you break it down, it means you are forming a different kind of matter, which may not be what you used to have. We can also define atom as the simplest particle of an element that can take part in a chemical reaction. Examples of matter or substances whose smallest unit we can confidently say is made up of atoms are metals, such as sodium, iron, magnesium, calcium, boron. All metals, their basic unit is atom. And then the noble gases, their smallest unit, which we are put together to form that gas, is also atom. So we can talk of neon, argon, and helium. Now let's look at a molecule. A molecule is a chemical combination of 2 or more atoms that can exist on its own. So we have looked at an atom. When I chemically combine 2 of these atoms together, I won't call that atom again, but it has now become molecule. So we can also define it as a group of atoms of the same or different element chemically combined. Let's take a look at some few examples. Some few examples of molecules are, we have oxygen. So we see this one consists of O2, meaning 2 atoms of oxygen chemically combined. CO2, 2 atoms of oxygen bonding with, so these 2 lines you see here is the bond, bonding with 1 atom of carbon. So it forms the whole of carbon dioxide. Then we can also have water, 2 hydrogens of water, 1 oxygen atom. So the dashes here you see are the bonding. And then starch. This is 1 unit of starch. So many of these units are put together to form the whole starch. So one building block of starch is in the form of a molecule. So this is one molecule of starch. 6 carbon, 12 hydrogen, 6 oxygen. You can count and see. We also have iodine. I2, meaning 2 iodines chemically combine to form it. Please, if you find a way to separate hydrogen from oxygen, you no longer have what we call water. You may have formed different kind of matter, but it is not water again. Then lastly, let's look at ions. An ion is the charged atom. When an atom becomes electrically charged, we call it an ion. Later on, we will look at how they become charged. So, examples of substances whose smallest units are ions, we can talk of salts, such as sodium chloride. So if you look at this unit here, we have sodium ion being represented by the green objects here, and then the chlorine by the blue objects here. So this is the arrangement. The dashes or the lines that you see here are representing the chemical bond. So this is one unit of sodium chloride or some part of sodium chloride. Another examples of these salts are magnesium chloride, and then we can also have calcium carbonate. They all have their smallest unit as ions. Now let's come to elements, compound, and then the mixtures. An element is a substance that contains only one kind of atom. Only one kind. So if I say this substance here is an element, I must see only one kind of atoms in it. And once again, it cannot be broken down into any simpler form. If you find a way to break it down, such as radioactivity, it means you are forming another kind of element, different from what it was. So an element, you must see only one kind of atom in that particular substance. Then, in nature, we have about 90 naturally occurring elements. We find them either in our aircraft system or in the atmosphere. Scientists have also been able to find other 30 artificially. But one thing about it is that they are very unstable. Unstable means that they don't exist in that form in which they were found. So they break down through a process called radioactivity into other elements. Now let us continue by looking at the periodic table. So far we have about 103 elements all grouped together in a special table called the periodic table. So here we are with the periodic table, and as a BECU student, you must equip yourself with the first 20. So find a way to memorize. Hello, lesson BBC, news of foreign news, new magazine. All sales personnel should call us potassium calcium. A way to help you memorize. So the first 20 with their names and symbols. These are the chemical symbol and this is the name. So if you take carbon, carbon is the name, the chemical symbol is C. The first 20 must be at your fingertips. A compound is a substance formed by the chemical combination of 2 or more elements or atoms. When 2 or more elements chemically combine, we would no longer call them an element, but the proper name to call them is a compound. The element may be of the same or different form. If I say may be in the same or different form, it means they can be of the same atoms being combined, or molecules being combined, or ions being combined. That is, I can combine, if you look at these examples here, I have a molecule of hydrogen, another molecule of oxygen, so I here different, and then they have formed water. I have an ion of sodium combined with an ion of chlorine. Here too, they are different elements. They are different elements or ions, sodium ion, chlorine ion, and I get a compound chlorine. Now let's look at this. For the formation of compounds, we can also term this as a chemical change. Why can we term this as a chemical change? Because one or more new substances are formed. So here, I have an ion. Let's look at this reaction. I have an ion plus sulfur to form iron 2 sulfide. This is a pure form of iron, and that is pure form of sulfur. But when they chemically react, look at what they form, iron 2 sulfide, which is a new substance compared with this and then that. So one thing about a chemical change or in the formation of a compound is a new substance is being formed. Then let's look at another thing about formation of compounds. Energy is either given out or taken in during the chemical reaction. That is, in the formation of compounds, it may either take in oxygen into the reaction system or it may give out energy. All right. The energy is usually in the form of heat. Let's look at this. In the reaction or in the formation of sodium chloride and water, these compounds from these compounds, that is HCl plus this rather gives out heat. But then in the formation of a compound CO2 from this carbon and oxygen, that one needs heat for it to take place. So note that in the formation of compound, energy may be needed or energy can be given out from the reaction. Then the change is usually difficult to reverse. Once you form the compound, it's very difficult for you to reverse to get back your starting material. So we say the change is usually difficult to reverse. The change can also be represented by a chemical equation. In the formation of compounds, which we can also call chemical change, we can represent it by a chemical equation. Then let's look at a mixture. A mixture is a physical combination. Here, please be mindful of the term. In compound, we say chemical, but in a mixture, we say physical, combination of two or more elements. A mixture contains substances which may be different and they are not bonded together. That is, there is no chemical bond holding the components of the mixture together. The formation of a mixture can also be called physical change. And examples of mixtures are alloy. That is when you mix two or more metals, when you dissolve sugar in water, when you dissolve salt in water, when you dissolve potassium permanganate in water. All these are physical processes. So that if I have this potassium permanganate, if I put it in water, it doesn't react with the water, it rather dissolves. And then what do I produce? After some time, it becomes evenly dissolved or spread in the water. So it is a physical process. Then let's look at bronze. That is the picture of bronze, a mixture of copper and tin. This is what we get. It's a physical change. And then brass, a mixture of copper and zinc. Also, we produce this, which is a physical also change as well. Then iron filling, a mixture of iron fillings with sand is also a mixture. It's not a chemical or it doesn't form a compound. It's just a mixture. All right, smoke. Smoke from burning particles is a mixture of the particles, the gases from the burning process and air. And sometimes pieces of the burnt material also mix with it. So this is also a physical process. Now, let us end by comparing what the differences are between chemical change and then that. In chemical change, new substances are formed. Here, no new substances are formed. Energy is taken out or taken in, but here no energy is involved. The change is usually difficult to reverse. Here, you can easily reverse the process. The change can be represented by a chemical equation. Here, the change cannot be represented by a chemical equation. All right, in my next presentation, we are going to talk about the writing and drawing of the atom for each of the first 20 elements, how to do the calculation and fill in your protons and neutrons. Then we shall proceed to look at